Okay, lecture 26. We're going to switch from telescopes to microscopes. Now, I'm sure you're all familiar with what we usually use microscopes to look at, right?
Yes.
And what's the difference between what you would do with a microscope versus a telescope in terms of the objects that you're looking at? So, for example, the objects that you're looking at with a telescope are usually very
Big.
far away.
Yes.
And, well, yes, big, right, I guess. You could look at small things if you wanted to that were far away if you had a really good telescope. But interesting problem, by the way, might be to reason through the idea, why is it you can't see the American flag on the moon using a telescope? Right?
It's on a specific side of the moon.
Well, no, it's on the right. It's on the side of the moon that we always see. Why can't we see it with a telescope? So it's an interesting problem. You can know roughly how big a flag is. It's not one of the giant flags they use. It's one of these normal-sized flags. But you could reason through what kind of telescope would you need, right, in order to see something of that size at that distance away. Okay, and maybe I'll make that a homework problem. So that sounds like a good one. Yeah. So with telescope, we look at far away objects, right?
Yes.
That's why we made this approximation that the rays were coming in almost parallel to the optical axis of the lens, right? And therefore, the focal length should the focal length of the objective should overlap with the focal length of the eyepiece, right? So that the eyepiece will now function as a magnifying glass for it. Okay. So microscopes, on the other hand, do we look at faraway objects with microscopes? No. When we look at things with a microscope, right, we put the object very, very close to the microscope objective, right?
Yes.
So it's a two-lens. Well, in truth, you can have more complicated microscopes, correct for chromatic aberrations and stuff like that. But a simple microscope would just need two lenses. An objective lens and an eyepiece, just like the telescope. The difference is that the objective lens and eyepiece focal lengths are both very small, okay? And so when we think of the object that we're imaging, right, it's going to be very close to the objective lens. Now, do we want it to be, what side of the focus do we want it to be on? Do we want the object distance to be less than the focal length or greater than the focal length of the objective lens? If we made it less than, then all we've really done is we made a magnifying glass. And we know there are limits to that, okay? You can't see, cells with a magnifying glass, okay?
Okay.
Because in truth, with a magnifying glass, you can't see anything any bigger than what you'd be able to see if you just put it up to your eye, right? So how big do I see things with a magnifying glass, right? Well, it will be as big to my eye as it is when I put it here, okay? The problem is, and we'll talk about the eye later in a lecture coming soon, when I put the magnifying glass between my eye and the object I'm trying to look at, right, this thing on the paper, this little cube here, appears really big. But if I put the magnifying glass here, it's going to appear the same size, but I'll be able to see it. I'll be able to focus on it, okay? That's what the magnifying glass does for me. So I can't hold a cell close enough to my eye to see it, right? So this is a little bit different. It's not a magnet. This objective lens is not acting like a magnifying glass, right? Instead, the focal length, the object will be beyond the focal length, okay? And we will image it with this lens. And its image will appear somewhere over here, right?
Yes.
Inverted as usual, because it's a real image, right? Now I'm going to use an eyepiece to magnify this even further, you see? And so the arrangement of the lenses is different than before. The separation between the lenses for an astronomical telescope was the focal length of the objective plus the focal length of the eyepiece, okay? For a microscope, it's the focal length of the objective plus the focal length of the eyepiece plus some additional distance L. I think it's usually called the barrel length. And that is really for realistic purposes of, you know, how tall do you want your microscope to be, and how tall are people, and if you had a really tall microscope, you'd only work for really tall people that could stand up and look into it. So this distance tends to be dictated by the height at which people stand and when they bend down to look, okay, and table heights and stuff like that. So but this is what you get, okay? The eyepiece is still acting like a magnifying glass, right? Because real images will be just, you know, it's set up such that the focal length of the eyepiece is, in truth, it's going to be a little bit less than what I drew here. It'll be, you know, something like here, right? And so this is just acting like a magnifying glass, okay? And as it turns out, the magnification for this is a little more complicated than what we had for the telescope. So a negative, yeah, of course, there's a negative sign because it's still inverted. And it's going to be minus L over F naught times 25 centimeters over FE, okay? This 25 centimeters we'll talk about when we talk about the eye and how the eye works, okay? This is called the near point of the eye, and that's the distance at which humans, right, can focus on an object in front of their face, okay? For a kid, it might be more like 7 centimeters, and for an old person, you know, Grandpa Joe, it might be 200 centimeters, okay? But 25 is just like the standard that people use. And so this has to do with where is the eye going to be in relation to the microscope, right? You can imagine an eye. Well, that's not very eye-like. An eye out here, right? Looking. And so you see that L is not all that important. What you really want to do is make the focal length of the objective and the focal length of the eyepiece very small numbers, right?
Yes.
The product of two small numbers is a really small number, and so when you divide a big number by a really small number, you get a good magnification, okay?
Okay.
Of course, it would be nice if everyone was 12 feet tall. We could use much longer barrel lengths, but not essential. So, this is the microscope. The big difference, telescopes, objective lens is a relatively long focal length lens. It's relatively flat, if you've ever seen these, right?
Yes.
The eyepiece is a short focal length lens. Microscope, both the objective and the eyepiece are short focal length lenses, okay?
Okay.
Understand?
Yes. Yeah.
Wow, awesome. Enough said then.